Okay, now I will start by chapter 10. Okay. So chapter 10 is the, let's say, I will start with the 10.1 curves defined by parametric equation. So let me give you some rough idea. So maybe I will give you some random curve like this, okay? And imagine that it's like object moving from one point, let's say from point A to point B. So A, we call A is the initial point. B is the end point. Okay. To give you the idea of what we are talking about. So parametric, of course, if you see the curve, or maybe if you see the axis, this is X, this is Y. Okay. If you see only the curve with the axis is X and Y, okay. The first question I can ask to is the curve one-to-one function? No, no. If you say no, you need to know how you can say no. Okay. Anyone can give me some answer why this is not one-to-one function? Yeah, the vertical line. So if you take some point in X and make a line, maybe here. Okay, let me give you some. Okay. So it's a little bit review of what we have done before at the early part of calculus 1. So if you take vertical line here, we'll see 1, 2, 3. So at X equals some number here, the Y will be 3, at least 3, right? It has 3 points, okay, in which it's not one-to-one functions. If you want to have a function, one-to-one functions, when you take vertical line, it needs to be 1x and 1y. Okay, just a little bit review. Okay. Now we see this curve, okay, from A to B, and interestingly enough, it takes some turns here, and it goes back. Okay, goes back. Okay. Now, in terms of parametric equations, this kind of curve, it might happen. Okay, the easy way to visualize why this happens is when you learn physics. Okay, when you learn physics, when you visualize some moving object. Okay, imagine the x and y is position, change in position, okay? But in 2 dimensions. It's not 3 dimensions. So in 2 dimensions, the horizontal one and the vertical one. Okay, so it's changing positions, and each time it changes positions, it depends on times. Okay, so maybe it start from maybe here is t, t equals 0, t equal 1, t equal 2, t equal 3. Okay, this is just a random number and random curve that I just want to show you how we visualize. Okay, so if you figure t as time, okay, and x and y is changing in positions, okay, so based on what we have learned maybe in physics, so each object when they move based on times, its position is changing. So we have, okay, we have x and y as a function of t. Okay, so let's say maybe I will write the same thing as the textbook, so to make it consistent. Okay, actually it can be f, g, h, as long as it is functions. Okay, and maybe g. Okay, so which means both of x and y have the same variables t. Okay, okay. And remember that I said t is time to help you visualize. Actually, t can be anything. Okay, it's not only time, but it can be anything that it can be parameterized. Okay, it can be anything. Because if you are thinking strictly to time, if I say can t be negative, can t be negative? It seems that if I write it's negative, it's like okay, I'm going backwards, right? So I'm time traveling. but actually t can be minus. T can be minus. Okay, t can be minus. So it's not about time that you are thinking of. Okay, it can be also time when you are looking from like you have a sequence, like when you are anyone editing video. No, so when you are maybe watching a movie and you want to fast forward and maybe move backwards, something like that. Okay, the t is working like that. Okay. But that's just for visualization. Actually, t can be angled and can be anything. T can be anything, anything that can be parameterized. Okay, and in this case, let me name this curve C. Okay, and let me write the t is from, let's say, A to B. Okay. So A and B is in which t equals some number here. Okay. Okay, so let me give you some examples. Okay. So if I'm giving you this equations for x and y, okay, for each t, you can randomly choosing t. You can at least curve, okay, curve what kind of graph will this looks like. Okay. I will draw it for you, but you can check. Okay, you can check. Or maybe I can write the table first, so you know how uh, to deal with this situation. Dx, y. So let's say we start from -2, -1, 0. Is 8, -1, 3, 0, 0. And the curves will be let's say this is 3, 6, 8. Okay, at least you get the idea. It's a parabola. Okay. However, when you are looking at the equations here, what you can do also is it should be okay. So you're looking at parabola y squared, at least okay, y squared. So the idea from these equations is you can actually substitute and you can substitute to these equations. Okay, and you can simplify this become y squared minus 4y plus 3. Okay, plus 2 plus 1. Okay, okay, correct. So if you're looking at this parabola and you want to look for the roots for this parabola, you will get the same curve. Okay, so that's one thing. So parametric equations, you can substitute or maybe simplify, and you can find the relations between x and y. Okay, but this is just an easy example that you can I can find this, and then it's easy enough to be drawn, right? But there are sometimes but most of the cases, because we are dealing with calculus, there are some parametric equations that you need to solve as it is. You cannot really change to the relation between x and y as good as this is, this one. Okay, so you need to think the calculus in parametric world. Okay, in this T world. Okay, but before we going to deal with the calculus part, let me give you also the example of what can be happening in the parametric. Okay, let me write this as x sine and y is cos. And let me define the t is from okay. Now t is from 0 to 2 pi. Okay. And again, if we are try to find the curve, trying the angle between this 0 and 2 pi, you will get a circle, right? A circle. And you can also think this as x² plus y squared this is become 1, right? So you can simplify this become this equations, which is the circle equations, right? And you can simply draw a circle. Okay. So the parametric you can modify or manipulate and try substitute to become an XY relations. Okay. If you have parametric x equals some t, y equals some t, some equation of t, you can substitute them, manipulate them, and try to find what is the relations. Okay. So this is another example. Okay. Before I go to the calculus part, uh, do you have you heard cycloid? The term cycloid? Have you heard this before? Cycloid? Maybe somewhere, maybe watching the movie? No? Okay, cycloid. Uh, do you think you need AC? You feel hot? Can you help me? Turn on the AC there. Yeah, just push the button. No, no, no. The two. There are two. No, no. Left. Okay. And maybe if you want, you can turn on the fan there and there, and check whether it's working or not. Okay. So cycloid. Okay. Uh, you have bicycle, or have you ride bicycle? Yes, right. Okay. So I will start with the bicycle, the tire. Okay. Uh, and let me make. So imagine, okay, the tire is rotating. Okay, it's rotating and move to the second one. Okay? So imagine it's move, rotating, and then move. So actually, it has a lot of circle actually, but I want to just showing you just two. Okay, so um, let's say we have the point maybe here, P. Okay, this is just my simplifications, but imagine P is going forward, and it will be ended somewhere in the second one, the P. Okay, because it's imagine it's like a bicycle, and if you put P at some point here, it will be ended up somewhere in this second part. Okay, let's say the second part, maybe here, or maybe here first, and maybe cycloid. Okay. At the third time, it will be moving, and it will be having another point, maybe here. Okay. So imagine it has a lot of movement here, okay? And if I'm connecting this P here and here at every possible point P, I can draw this P. Okay. So it will be from there, and then it's continue one more time, continue again, and that is cycloid. That this red line is the cycloid. Okay. Let me draw one more circle, and let me break down what will we observe. So this P, maybe this is the cycloid one. Okay. And from this P, I will connect to, let's say this is the center of the circle. And let me choose the different color. Okay. And let me make another one down here. And maybe y-axis. Let me name the center. Let me use the same name as the textbook. CQ. Okay, CQ. And inside is theta. And all the same radius. Okay. So radius R, radius R. And then the other, this will be O, the origins. Okay. And let's say this is T. Okay. Okay. Now, let me make bigger. Okay. Now this OT. Okay. To give you a rough idea how we deal with this one, this OT, imagine O is the first starting point for P. Okay, so before P going here, P is here. Okay, so imagine you roll the circle and P is here. Okay, and P is moving right over here, right? So if you imagine from PT here, all this PT is rolling up this OT. Okay, so I can write that OT is actually equal to, or let me write in more correct terms, the distance of OT is equal arc of PT. Okay, you get the logic. Okay, the arc here. Okay, so what is the arc? You can get the arc from the ratio of the angle, right? The angle for this one is this theta over the whole circle, right? So we can write this r multiplied by, or let me just write r and theta. Okay, and it will be the distance pt, the arc pt, and we can say in this situations pt is equal to the distance of ot. Okay, let me define this as it is. Okay, and then let's see, we have distance x here. Okay, x is ot minus pq. Okay, let me write that. So I will have r theta minus pq is r sine, right? R sine theta. So we can have these equations here. R theta minus sine theta. Okay. And then y is this one. It's the TC minus CQ. So the R minus CQ. So let me write TC minus CQ. Or R minus R cos theta. Or R1 minus cos theta. So I can write generally in cycloid, we have x is R and y is 1 minus cos theta. And we can also write theta is real number. Okay, any questions first? Any questions? Okay. So this is also example for the parametric equation. Okay. Parametric equation. So what is the parameter here? What is the parameter? What is the parameter? The variables. Yeah, yeah, theta. Okay, only theta. The r is a constant. Okay, because if you ride a bicycle, if r is changing, it will be disaster. Okay. Yes. Oh, maybe here, right? Okay. Okay. So what we are done here, we are dealing with the 10.1, defining the curves, the parametric curves. Okay. So I hope you get the idea of the parametric. Okay. I think I will just skip the exercise part for 10.1 because mostly it's about the description of the curve, etc. You can just using your computer if you want. And I will go directly to 10.2. Okay. Okay. Let me write another page. So 10.2 is calculus with parametric curves. Okay. Now I'll write the idea once more time. X is function of t, y is also function of t. The function is f and g. Okay. Let me write this. Suppose f and g are differentiable. Okay. Remember, differentiable, you need to define that by yourself. And it's on calculus 1. I will not repeat what is differentiable. Okay. So suppose f and g are differentiable. We finding the tangent line. Okay, let me write finding the tangent line at a point on curve x equal f of t, y equal g of t, and where y, let me change to where y is also differentiable functions of x. Okay. So we are still keep this as our definitions. Okay. So we have this, okay, but we have also this. So based on the chain rule, we will have or we can write this as and dx dx over dt, suppose it's not to be 0. Okay. Or maybe you can also write uh, like this if you want. Same concept, same meaning. Okay. So if you want to find dy over dx, where y is actually a function of x, and y and x, each of them can be defined in parametric in t. Okay, so we can find the relations through the chain rule, and basically the first derivative of y with respect to t divided by derivative of x with respect to t also. Okay. So let me give you just a quick example, and then how we can approach the second derivative. So let's say example. Just a quick example. So to solve this, you can solve in two methods, okay? At least two methods, because the equation is simple, that's not too complicated. You can substitute this one of this equation to other, and then solve in x-y relations, and you find dy dx easily. Or you can solve by parametric calculus, in which I mentioned in chain rule before. Okay. Or maybe to make it exactly number or answer, maybe at t equal 4. And remember, if you have this kind of question, find dy dx at some t here, do not plug in directly to x and y, this t equal 4. Because it will be useless, right? If you plug in 4 here, it just tells you the positions. Or if this is in case of positions, right? If you plug in t's 4, okay, y is 5, x is what, 4, 16 minus what, 8. It's 8. Oh, 5, 8, 5. And then, well, what is happening, right? So don't do that, okay? So remember, this is changing over time or over some parameters. So what you can do, you need to define the equations first, okay? And then at the end of your equation, you plug in your t, okay? If you did a mistake, you plug in t at the very beginning of your equations. I'm suggesting reviewing all your basic math calculus matters, because that's very basic. And yeah, just a warning, okay? So to find dy over dx, you can go for substitute this 2, and you get y equal 2 plus and dy over dx become we need to have x. X is 8, so this is 1, 2. It is 1 over 6. Or we can, let me change the other column. Or you can have the y over dx. What's the equations? So it's 2 to t. Wait, okay, wrong. Should be 1 over 2t minus 2. and t is equal 4. So it's 1/6. Okay, same thing. Okay. Now let me add the questions. What is the second derivative? So what is this? The second derivative. So the first question is dy over dx, no problem. We get 1/6, both of our approach. And what is the second derivative? Mm, let me help you to write. This is 1, right? Okay. So what is the second derivative? So dy d squared y. So can you correct me? Is this correct or no? Okay. 0, 0, 0. Hello. Second derivative. Anyone agree with this? Okay, who disagree and why? Yeah, disagree? No? Can you tell me why? Okay. The definitions, we need to stick to the definition first. That's the rule. Okay? The definitions is y is function of x, right? So every time we did something with y or with uh, either derivative, second derivative, it will happen to in relation to x also, right? Because of the domain is in x. Okay, this y. Okay. What we are doing here is it seems correct. It seems correct. Okay? But we are doing it exactly as before. You know what I mean? Second derivative means if you try to correctly writing these terms, let me write here. Okay. This is, or let me write here. Let me write from the very beginning so you get the understanding. So if I write dy over dx, it's actually the tools is d over dx and then y, right? Okay. Second derivative meaning is we differentiate one more. We are doing d dx one more time with this, right? So the idea is, let me change color. So we are doing another d dx, right? So imagine d dx is your tools like in your computer. You are writing, okay, you deal with something, you through the DDX, and it will say, okay, I'm deriving, I'm differentiating something here. Okay. So second derivative meaning we are doing one more derivative, one more DDX to this function. Okay. So this is the correct definition. Okay. Because we need to remember that y is function of x. Okay. Now, if you want to correctly relate Okay, if we want to connect, okay, dy over dx with parametric t, in which we already defined before, then what we can write is or let me move to this side and make okay. So we cannot directly solve, okay, or differentiate the top one and then the bottom one. Okay, one more time, top one, bottom one. It will destroy our definition at the very beginning. Okay? The very beginning of the definition is y is function of x. Okay, that's you need to remember. So anything to be related to the in y is also x. Okay, it's also involving. Okay, and again, if you want to find the third one, and then you keep the same ddx2, and then this one will be the second derivative. Okay, okay, and then you can go for fourth, five, but let's just stop until this two. Okay, I hope you get the idea. Okay, so let me write this is wrong. Okay, let me write this wrong definition, and this is definition. Okay, okay, so I have at least 40 minutes. Okay, let me give you example after this. Okay, I'll give you some couple of minutes for you to write, and maybe if you have any questions, feel free to ask. Okay. Okay. Any questions? No. Oh, you want to the value? You can just checking this one. Dy over dt. Dx over dt is 2. Oh, wait. Sorry. I wrote the wrong thing here. Sorry. So dy over dx is, we already got the 1 over 2t minus 2, right? So let me write in example, dy over dx is 1 over 2t minus 2. So you need to derive this one more. So at least you need to It's 0, 0. Right? Yeah. This is, and then over dx over dt is what? Dx over dt 2t minus 2. So it will be 2t minus 2. Okay. Yeah, correct, right? Anyone can check for me? So this should be the definition. Okay, sorry, before I'm writing the wrong thing. So it should be dx. Yeah, I think that's correct, right? And if it's asking t equal 4, then you can just plug in the number. Yeah, you can calculate 108. 108, yeah. Okay, let's move to the next one. Um, suppose the class is up. Let me ask you, okay, which one you prefer? Okay, our schedule is actually until 12:10 officially, right? Usually every bell ringing, there will be like 5-10 minutes break. You want to break or you want to finish early? Early, okay. I also prefer that way because if I stop and then you break and then to start, so it's kind of like you know uh, when you do something like any activity like study or um, study is not fun. Maybe you're um, active in sports. Okay, maybe you have exercise. You have to like maybe tournament, maybe basketball tournament, and you want to compete each other, right? Sometimes if you don't do like routine exercise, and maybe you stop at the very middle. Sometimes if you are not familiar with the exercise, when you need to start again, you need really high energy to do that. Okay? That is nature. Okay, that is nature. Like I always say this, like in the last semester, when you wake up in the morning, it's usually very hard, right? Because when you sleep, it's comfortable, right? In physics or in energy, there is some terms called activation energy, in which if we are pushing the energy until some momentum and maybe above that energy, we will be okay activated. But if not, then okay, I'm still in sleeping position, or we call dormant. Okay, dormant is the terms. Okay? So sometimes you need to take some risk with high energy to do something, to change your attitude, to change your lifestyle, your habit, anything. Uh, like actually, if you want to be good at anything, you only need there is a book. The first saying that at least if you want to be extremely good at anything, you need at least 10,000 hours. But it's more like extreme, really high quality, high powerful, blah 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 blah. Like the comparable is like an athlete really good at in sports maybe. But actually, if you are just okay from you cannot do something, some skills, but eventually you will be good. You only need 20 hour. 20 hour. It's good enough to help you good at something. So I don't know. Maybe you can try and give it a shot. Anything that you find interesting, skills, hobby. Maybe if you are dealing with a how to say that like programming seems difficult, but if you try to 20-hour, try understand the beginning of it. Any skills, actually, any skills. You try to boost your confidence. You maybe you are not really familiar when you try to speak in front of everyone in the public. Maybe you can try and really push yourself and do it, and eventually you'll be good. At least 20 hours. Try 20 hours. That's the some research that the 20-hour code. Okay, yeah, you can try. Okay. I'm not sure how you are study, but you need to find your own way of studying. Okay, I'm not like okay, you need to study or write exercise. No, no, no. Everybody isn't the same. Okay, sometimes you just need maybe a little exercise, and then okay, I remember I will be good at this. Blah blah blah. That's okay. But maybe you need to draw, like mapping your idea, and then okay, this is my plan. Blah 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 blah, and then you'll be good at it. That's also I think that's also good. Okay. So my motivation for you, okay, it's okay to be lazy. It's okay to be lazy, but you need to be smart. Okay, lazy but smart, it's difficult. But lazy but still not smart, and then you will be regretting your life. Okay, lazy is a natural way of life. Everyone wants to be comfortable, right? You have the smartphone, you have all the information. You want to have food in your door, you can order the food, and then you can have your Uber, your Food Panda, blah blah blah, right? It's because we want to be lazy, right? So it's okay to be lazy, but smart. Okay, that's my statement. Like last semester, I always say that. Okay. Okay. Anyway, okay. Let me give you another example with with some different questions. Okay. So let's say we have x equal t squared, y equal t cubed minus 3t. Let's say uh, a curve of c is, let's say, defined by these equations. Okay. Number one is show c has two tangents at point 3, 0, and find the equation. Number two, find where tangent is horizontal or vertical. Determine the curve where the curve So it's like reviewing some part of calculus 1 also, but in parametric. The curve is concave upwards or concave downwards. And then maybe sketch the curve. So in this way, calculus also can help you to sketch the curve in parametric, okay, by determining some essential key, okay, like the horizontal tangent, the vertical tangent. That's some essential key in this parametric, because in parametric, the graph can be curvy, like it can be going circle. It can be. Okay. So I'm giving you some couple minutes, or maybe 3-5 minutes to try first and see if you still remember the idea from calculus 1. Okay, let me solve the first one. So shows curve C has two tangents at 3, 0. So 3, 0. So x is 3 and y is 0 here. So based on our parametric, x is t squared. So 3 can be, or let me write, t can be plus minus square root of 3, right? And y is t squared t cubed. Or I can write this as t squared minus 3. Both cases, okay, if you are squaring this plus or minus, both will be 0, right? So it's still correct. So it's correct that it's 0. It's correct, it's 0. So what's the questions is the tangent. Oh, the tangents. Okay. So we have at t positive square root of 3, then dy dx will be, or let me write the general rule first so it will be more structured. Okay. And then we are going to check the t equal positive square root of 3. Then it's resulting three over square root of 3. This is square root of 3. Right? And the other one is negative, right? Okay. Now we need to find the tangents for these two cases. So the tangents we can find through the line equation. This is dy dx, right? And x, y is 3, 0. So I'm just putting all together now. So so we have first, it's becoming x minus 3. And when dy dx is negative square root of 3, okay, then we can show you this is the two tangents. We have two tangents. Okay, the second one is horizontal or vertical. Okay, first is the horizontal. Horizontal tangent, if you, so let me give you the idea, okay? If you see the tangents going up, right, it's positive, okay? And then if it's going down, it's negative. So in between, there will be 0, right? So the tangent should be 0. So let me write this. quickly, it should be 0. Okay. Now, how we get this 0? Let me break down this to two parts, dy and dx. So this should be 0. This should be not 0. Okay. So dy over dt is 3t squared minus 3. It should be equal 0 because our definition of horizontal tangent in parametric. Okay. If the 0 and 0, then it's indeterminate forms, right? So we need to go for 0 for the dy over dt. And we can solve this, or we can directly just say that this is plus minus 1. So when t is positive 1, x will be 1 and y will be minus 2. Let me write one more time here. So when t is 1, and try to plug in, because the question is asking where the horizontal tangent will be. So you need to give the positions. Okay. So t equal 1, so it will be on 1 and -2 and -1. So plug into the original equations, we get 1, right? X1 and -1, it's 2. Right. Okay. So this will be where the horizontal tangent will be. Okay. Next is the vertical tangent. Let me write here, vertical. So the vertical tangent is this, right? Meaning it's infinity, right? Or undefined if you want. So vertical tangent dy dx is undefined. Meaning, if I write this into parametric, what undefined means is this is 0, this is not 0. Okay? Got it? Undefined. It's not the same as 0 over 0. 0 over 0 is other different from this. This is when you have 1 divided by 0 or 2 divided by 0. If you calculate, it will be infinite, right? Or we call this also undefined. Or at some point, you can also call this an infinite number. Okay? But we usually call this undefined. Okay? So we can check the dx over dt, in which it's 2t, and it should be equal 0. So t is 0. And when t is 0, x is 0, and y is also 0. because there is no constant, right? So 0 and 0. So this will be vertical tangent. And this will be horizontal. And now we can draw maybe here. Or maybe one more thing, the concavity. Let me write here. The concavity. Okay, concavity, remember, we need to derive it from the second derivative, okay? And we know from previous slides, in parametric, we need to go for this root. And okay, now we can input our the first answer is 3t squared minus 3 divided by 2t, right? And dx over dt is on the 2t. Now solve the first one. We get -60 minus it will be 12t squared minus 2 3t squared minus 3. Right, 60 2t, yeah, 12t, right? And we can write this solve okay, at least we get the equations. Okay, this is our second derivative. Okay, this is the second derivative. So what concavity tells us? Okay, still remember what is the concave upwards, downwards meaning? Yeah, you need to decide. Okay, so concavity, concave. Let me write concave upwards if the second derivative is positive, right? And concave downwards. Okay. Now, what can we do from here? Okay. Can you make some conclusion? When the concavity is upwards, when the concavity downwards? How? The idea is just taking the okay, because no other set of number here, then you might try 0, right? Okay. And then try find from this line number. If it is positive t, it's positive, right? If this is negative t, because of the cube, it will be negative, right? Okay, got it? Got it? This is t, okay? So this will be positive and negative. So concave upwards is t is greater than 0, and concave downwards t is less 0. Let me draw here. Or do you want to write here? Okay. Let me give you a couple of minutes and let me draw all the things. Yang DDT kan diubah ke parameter. Okay, let me draw the curve. Charge is 0. Let's say this y-x. Okay. So let's check all the informations. So this horizontal is x equal 1. So let me write here 1. And this is 2. This is negative 2. So we have here the vertical tangent here. And this point will be 3.0. We have 2 tangents here, right? One is here, one is here. Let me use the other color. This is t equal minus 1, t equal 1, and t equals 0 here. So if you see, we will connect from negative 1 through here, and eventually go here, okay? Because when you have t equal 2, it should be around here. So it should be move forward here, right? Because we already proved that 3, 0 is on the curve. So going here and there. So we need to carefully draw that show this. This is a horizontal tangent here. And going down here. And here. And this going up, this going down. So this is the arrow. Yeah, and so maybe t minus something is here and then go here and that way. Okay. And show that this is the horizontal tangent. This is also horizontal tangent. This is the vertical, and we have 2 tangents here. Okay. So again, despite the complexity, how we solve and sketch the curve is actually using all the tools in the calculus 1. Okay. the difference is we need to change all the formula into parametric, okay, into parametric. Okay. So we need to have the DDT, okay, instead of just DDX. Or maybe I will add this t here is t equal or t equal negative. They both at the same positions, right? From our calculation before. Yeah, and more, if you see some exercise, they will give you this kind of curve, this kind of curve. Okay, I think I will stop here. And the next week is, yeah, Monday is holiday. So we will see you again Wednesday. I will move to the integral, the arc length, surface area, and then emphasize more in the polar. Okay. If you have any questions, you can ask me, or maybe after the course. It's okay. No, no.